All right, guys. So, this is the second half of 12.4, so you should have already watched the first half. If you haven't, please watch that first. But we are on example 4. Okay? So it says out of 200 students, and I'm going to highlight here. So we have 200 total students in the senior class. 13 are either varsity athletes or on the honor roll. Okay. Then there are 74 who are varsity athletes, and there are 51 who are on the honor roll. Okay. What is the probability that a randomly selected senior is either both a varsity athlete and on the honor roll? Okay. So we want to know the probability of A and B. All right. So we know that, well, first let's just write out what we know. Let's let the probability of A be the probability that we're a varsity athlete. Okay, and the probability of B is the probability that we're on the honor roll. Those are the two things we're talking about here. Okay, we know they're all seniors. It says 113 are athletes or on the honor roll, so probability of A or B is the probability of athlete or honor roll. And we want to find the probability of A and B, which is the probability that they are an athlete and on the honor roll. That's what we're going to find, so I'm going to put a question mark here. All right, so let's start plugging in what we know. We're looking at the 200 seniors, okay? 113 out of the 200 are athletes or on the honor roll. So probability of A or B is 113 out of 200. Okay? 74 are athletes. So 74 out of the 200. And honor roll, we have 51 out of the 200. We want to know what's the probability that they're both an athlete and on the honor roll. Well, clearly, this is overlapping. Okay, so we're going to use the probability of A or B equals the probability of A plus the probability of B minus the probability of A and B. Okay, now let's plug in what we know where we're supposed to. So, probability of A is 74 out of 100. That goes right here. Or 74 out of 200, I'm sorry. Probability of B is 51 out of 200. That goes right here. The probability of A or B, which goes right here in the front, is 113 out of 200. And then I'm going to put minus, we don't know this, so I'm just going to put X out of 200. Okay. Well, let's simplify this. 74 plus 55 is what? 125 out of 200 equals 113 out of 200 minus X out of 200. Okay, so let's subtract 125 out of 200 on both sides. So I get negative 12 out of 200 equals negative X out of 200. So X then would be 12. So basically 12 out of 200 is the probability of A and B. And if we divide 12 out of 200, that's roughly 0.06. That should be your answer. All right, let's work this one out. Okay, it says the American Diabetes Association estimates that 8.3% of people in the United States have diabetes. Suppose that in medical lab, they've developed a simple diagnostic test for diabetes that is 98% accurate for people who have the disease and 95% accurate for people who do not have it. So we have a stipulation here, okay? The medical lab gives a test to a randomly selected person. What is the probability that the diagnosed is correct? All right, so we have two different events we're looking at. The first one, let's let the probability of A be the probability that a person has diabetes. Okay, and let's let the probability of B be the probability that the test is accurate. Okay. All right. So let's go back and reread this. We estimate that 8.3% of the people in the United States have diabetes. So the probability that you have diabetes is 0.083. All right, suppose that a medical lab has developed a single diagnostic test for diabetes that is 98% accurate for people who have the disease. Okay, so that means the probability of the test being accurate, given that a person has diabetes, equals 0.98. Okay, and it is 95% accurate for people who do not have diabetes. Okay, so the probability of being accurate, given that you don't have diabetes, is 0.95. All right, so probability of B given not A, we need to have a probability of just not A then. So if the probability of A is 0.083, the probability of not A is 1 minus 0.083, which would just be 0.917. All right, so I'm going to draw this out, and I want you to think about this. So the probability, we want to know what's the probability of having an accurate diagnosis. So we want to know the probability of B. So the probability of B, probability of given an accurate diagnosis, would be, well, we can have an accurate diagnosis in two scenarios. It'd be the probability of you having diabetes and getting an accurate diagnosis. Or we could also have the probability of not diabetes but also getting an accurate diagnosis. Okay, so probability of being accurate, we have to look at two different scenarios. We have to be it having diabetes and being accurate, or you don't have diabetes and it being accurate. Okay, well, the probability of A and B, well, let's just write this in one big thing. So the probability of B equals the probability of diabetes inaccurate would be A and B, or plus the probability of not diabetes, so not A and B. Okay, well, these two numbers differ depending on whether or not you have a diagnosis, and therefore we are talking about dependent events. Okay, so this is going to be, I missed my B there, the probability of A times the probability of B given A plus the probability of not A times the probability of B given not A. Okay, guys, I have all these numbers right here. Don't freak out on me. Okay, so the probability of A is just 0.083 times the probability of B given A is right here, 0.98, plus the probability of not A, 0.917, times the probability of B given not A is right here, 0.95. Okay, so if I put this into my calculator, I get that this test is roughly 0.952 as a probability, which is roughly 95.2% accurate. Okay, so this is the probability that it's accurate. What is the probability that it is inaccurate? Well, guys, remember, that's just the probability of not B, which is 1 minus the probability of being accurate, which is 0.048. It's a 0, or about 4.8% of the time it is not accurate. All right, I want you to go ahead, use example 5 to go off of, and try to do this one on your own. Write it out like we did first. Find what your two events are, and then individually find, read through this word problem and find the probabilities of those events. All right, so this is what you should have gotten, okay? So the probability of A is the probability that you have a halftime lead, which is 0.6. Probability of B is the probability that you win the game. That's what we're trying to figure out, okay? The probability that you win the game, given that you had a halftime lead, is 0.8, but it drops to 0.1 when you don't have the halftime lead. So probability that you win, given that you don't have a halftime lead, is 0.1. And therefore, the probability of not A, because the probability of A is 0.6, the probability of not A is 0.4. Okay, when we plug that in here, you should come down and get 0.52, or 52% of the time they win the game. All right, I want you to go through and do parts A and B on your own. For each part, make sure you answer the 4 parts of the question. These should be pretty easy. Okay, it should only take you a minute, and then we'll go over them. All right, for each of these, this is what you should have gotten.